But don't humans have an instruction manual? An instruction manual that's been encoded in our genes and filtered out via the process of evolution?
We're going synthetic, baby. I don't think we're going to run out of anything to train on, probably ever.
That doesn't make any sense to me. That's just photocopies of photocopies. It won't work for long.
A lot of the things there don't make sense, though, intuition-wise, right? There was a paper discussing prompt tricks, and there was like the seminal let's think step-by-step prompt trick that made the models perform better. And there was a paper recently that said, if you prompt, take a deep breath, and then let's think step by step to completion, then it's like the best prompt. Now, why? That's unintuitive, I think, as well. And so a lot of the intuition that we currently hold, I don't think will generalize Naval. In terms of synthetic data, Tiny Stories is actually showing incredible performance with 1.5, PHI 1.5. It's a synthetic data set, and this model, very tiny model, I think Andrew mentioned this before, is outperforming some bigger models, and that's an entirely synthetic data set. An additional point here is I weekly have conversations with News to Essential, Alignment Labs, GarageBand, like all of these folks, and all of them say that the same data, literally the same data, just formatted differently, gives better results. So essentially, photocopies of photocopies, I mean, by this metaphor, you're saying the quality decreases. An additional point here is that the datasets could be synthetic, but still labeling, for example, could be human, or there could be a mix of working through data and then labeling it differently. The metaphor you used, photocopies of photocopies, I don't think applies here strongly, just because it implies loss of data, continuous loss of data. It's like taking a JPEG and compressing the JPEG and compressing the JPEG, etc. This is not the case here. You don't necessarily compress, because it also expands differently with temperature, but it also expands, right? So the output of GPT-4, it's not a compressed input. It's a completely entire new thing.
So in order for AGI to develop, there needs to be agency which will allow it to have its own philosophy using Rand's basic structure of, metaphysics, epistemology, ethics, politics, and aesthetics. I know it's not probably the best base, but generally speaking.
Alex, these are techniques for unearthing more data that was already in that data set but wasn't captured properly the first time, or maybe refining the data set, but it cannot fundamentally create new data. The data is already all there, so it will have diminishing returns. And so I think the photocopy of a photocopy analogy does apply. You either have to be inputting new data from the outside, or you are unearthing data that was already there from the inside and you will run out, but there is no free lunch.
I hear you on the amount of data, but let's say that all the words in all the languages are in the data set already, so the model can have all the words. Then you ask the model to help you with the task of refining data or augmenting it. By augmenting, I mean take a data set that's high quality that you only have 20 samples of and create 100 samples of the same quality. The models currently are already able to do this. Don't you agree? Wouldn't you agree? And so are those new 80 samples new data? Because the words are rearranged differently, maybe in such a different way where no person before in the original data set of the training rearranged them this way. So it's for sure clear that this helps model be better. So the higher quality data set, the higher, the better performance of the model. It's been pretty much proven to this point, at least with this architecture. Maybe other architecture will be different. I hear you on the point of new facts. I think you're referring to that, or you were referring to that at some previous point, where we don't see these models fundamentally give us new information necessarily. But I think in terms of just training, and this is all I was talking about, just like synthetic data. And by synthetic, I think I was mistaken as well when I said like synthetic, and I felt it meant completely synthetic. Like, hey, GPT-4 generate a training data set for me, and then it's basically distillation. You take one good model and you use it to train a smaller model. But synthetic augmentation of data, synthetic, like if you take 10%, 20%, just like of good data and then make it into 100%, and like 80% of this is LLM based augmented, that is going to make sure that we don't run out of data to train on. By the way, I haven't trained any LLMs myself. I've trained an image model a few times, but I'm talking to these folks weekly, to News Research, to Alignment Labs. Those are the folks who are collecting data sets and are topping the charts of open source models. And their constraint is not data, actually. Their constraint is compute. So I think for the big labs, for OpenAI and everything, data, and I think, they're moving into multimodality. So I also don't think the data for training is going to end. I think Dario Amodei also said something about this, but he wasn't willing to extrapolate on why he thinks this, maybe because it's their competitive advantage.
That's a very interesting point. I mean, data augmentation is a very, very standard technique in machine learning, where you take, so in image models, if you want to train on images, very often what you'll do is, instead of just taking, let's say there's a picture of a dog, right? What you'll do is you'll add to that data set by creating the same image, but you'll rotate it slightly, or you will change the color slightly. And so you're teaching the model to like, hey, don't overtrain on just like the perfect image of this dog. Train on also the variations of this dog that I know are still a dog. And so you're sort of encoding some priors and actually you're multiplying your data significantly, but it helps the model to be more resilient to small deviations that you as a trainer know, like, hey, a rotated dog is still a dog. Naval, to your analogy of, hey, garbage in, garbage out, like how is this not just going to cause errors to amplify? The analogy I would give is, imagine I lock a human being in a room for a year and I ask them to get better at writing essays. I think they could. I think that obviously would succeed. And maybe that's the analogy for how you can think about these models. If you sort of give them the right initial push in the direction of improving at generalizing on some particular set of data, data augmentation, generating more synthetic data for them to train on. Maybe that's the best analogy for thinking about how it is that a model can actually improve, so long as a human being kind of gives that initial push in the direction of better priors in its training set.
I feel like a lot of the challenges, and to Naval's credit, come with what Brett has also said, the deviation from the norm. So looking at basic language principles, we have slang, and sometimes those slang become so ubiquitous that they are now put into the dictionary, or how words change over time. So like the word nice was usually originally for someone that is pretty ignorant, for the soft version of that. But now it is someone who's considerate and kind. So that human creativity factor to deviate from the norm and create something new, or create changes in language, is something that would have to be programmed in some way, shape, or form, which, once again, it would be hearkening from a data set and not quite creativity, but it can have the guise of that. And I know that Brett has already covered a lot of this too. But the fact of the matter is, when you really lock a person in a room and ask them to write on essays, you're going to get some crazy stuff. You're going to get writing on the wall. You're going to get someone by the end of it who might not be all there. So these are things to consider within the analogies being proposed.
I agree with you from the data point of view, but we are just getting started from the mathematics point of view. This is just building up the basic Riemannian geometry, just all the stuff they figured out for modern math, like real math, since Gauss. That's all this is now. This isn't even like the quaternions, octonians, like these other algebras that work. So just like with three-dimensional geometry, it all works. Nothing was wrong, but these other geometries also work and fit into it and have a lot more finesse to them. that will be, I think, what ends up happening with data. That nothing to do with the data. The computational techniques are you get better and better. This is like the most powerful math we've ever known, fully unleashed, and it's only going to get better.
To improve the model, new data has to be entering from somewhere, or new creativity has to be entering from somewhere. Because these things are not yet AGI, new creativity is not coming in. So new data has to be entering from somewhere. In the example of locking a guy in a room and he practices until the essay gets better and better, what is giving him the feedback that the essay is better? If the feedback is coming from his own creativity, then he is already intelligent, he is AGI, and that is not the case here. If the feedback is coming in from the outside, that this is good, this is bad, then the data is coming from the outside. So that's why I think training on synthetic data and just saying we're somehow never going to run a data so keep getting better and better is a false god. Because there is new data coming in. That new data is coming from the outside saying this is right, this is wrong. And that is a perfectly valid form of data. So synthetic data is part of a technique to bring in new data through human feedback, but it is not itself the source of the new data that is leading to better and better intelligence. Otherwise, you could just build a small model, lock itself in a room, and then it trains itself on synthetic data from here until it hits AGI, and we know that's clearly not the case. This is just hand-waving with fancy math words and dodging the question. Where is new data coming from for new learning? New data must input the system, enter the system for new learning to take place, or existing data that was already inside the system has to be exposed and it wasn't captured because of inefficiencies. So you're just retraining the model on the same old data. You cannot get something for nothing. There's no perpetual information motion machine here. Instead of saying, well, researchers are using synthetic data and saying it's working, that's just credentialism. That's just falling back on somebody else's claiming that they have accomplished something. What is the underlying good explanation as to where the new data is coming from? And I would argue that in all of these cases where people are citing synthetic data or hand-waving about fancy math, what is actually going on is that in the first training run, not all the data was taken into account. So you are now unearthing data that was already there. Or you're using a bigger model to train a smaller model, so you're extracting data from the bigger model and feeding it to the smaller model. Or you're getting feedback from humans saying that essay was garbage, you can do better, oh, this one is better, and that is the new data entering the system. So in any case, either data that was already there but wasn't being used is being extracted, or data is being fed in from another AI or from a human. That's really what's going on. So this idea that the models will never run out of data because they can just generate their own data ad infinitum is completely false.
No, I don't think so at all. I think I agree with you that more data isn't going to improve the same existing tools. I'm just making the observation that the tools underneath are going to get much better, and that same data will yield far more intelligence analysis results when it's looked at with just better analysis. And we are headed for better analysis. That's the point I'm making here. And it is a little mathy in that there's a parallel. Like, if you only do calculations with, let's say, the real numbers, you can only go so far. If you invent this other system of mathematics where one of the axes doesn't behave in the same way, complex mathematics, all of a sudden your math gets incredibly more powerful. And that's what gets you electromagnetic field theory, strong theory, weak theory, like everything comes along with the mathematics that culminate with that stuff. So my point here is that all that we've seen with this statistical inference, that is just like the coarsest comb that we have. When we start getting into like more powerful mathematical tools, it will reveal more powerful insights.
Yes, new techniques can extract new learning from old data. I was just pushing back on the whole synthetic data argument that the AIs won't run out because they can just keep creating more data themselves. No, we need data from the real world, from reality. We're always just approximating closer and closer to reality, and we always need the world as an oracle to provide us with data and feedback.
Oh, I see now. You're totally right. Like, you can't take your estimates, like, you know, we've averaged these 8 things, and now we're going to take the average of those 8 things and break them down into 16 things. There's no advantage there. That's already happened. I was more stumping for the idea that, like, there's the data that goes into it, but, you know, the endpoint of these models isn't coming up with the English language. It's just ever improving functionality to translate it or aggregate it for us. And that I still think has room to run outside of like just more data, i.e. more sophisticated techniques.
This was basically the crux of it. Well, new techniques, including synthetic, like data augmentation, everything, are extracting better and better insights from kind of the existing text that we have. The whole point of we're going to run out of data, so progress will stop. This is the original comment of we're going synthetic. So agree with you about credentialism. Definitely, there's more to explore. I have two, how should I say, pillars of this thought in my mind. One of them is I saw a paper about training Stable Diffusion on Stable Diffusion generated images, something that when Stable Diffusion was released a year ago, I asked Imad in the Stable Diffusion kind of Discord about, hey, are we not going to pollute all of the imagery on the internet with AI generated imagery and have a photocopy effect that goes like spiraling down? And even back then they told me no. And then I think I saw a paper. I could not find this now. I really wanted to like go find this and bring this to this debate, discussion, exploration, what have you. And there was a paper that said they've trained a version of Stable Diffusion on Stable Diffusion images, and it achieved a better, higher score. I think you absolutely hit the nail on the head where smaller models get better performance by distilling from data that's already in another machine like GPT-4. That's 100% true. I think this is kind of most of what I was talking about, at least. GPT-4 is kind of the best model. Some folks call it distillation. Some folks call it, they just use this tool for other tools. But it's not necessarily the case that, models of the size of GPT-4 would benefit from synthetic data. It's not 100% the case, for sure.
Pardon for the deviation of topic here a little bit. In my case, if you're an inventor, an innovator, and you have new data or novel data on something, if you were to co-create with AI on writing a patent, you would be able to train the AI to understand this new data. If I'm not mistaken, can you guys elaborate a little bit more on that point? Okay, so to clarify my last point, to make it a little clearer, sorry. You, as an inventor, have access to novel data, which is not open to the general public, which means it's not in any AI system. Let's say this novel data is made up of steps 1 through 4. Now, let's say you create a patent, and you decide to create this patent with an AI system, but you don't disclose steps 1, 2, 3, and 4. Rather, you use steps 1, 2, and 4. You omit step 3. Would AI be able to reach the same conclusion as you have without having that little piece of data? Or would it be able to put steps 1, 2, and 4 together to generate step 3?